Example 2, a lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left or right from the shown starting position. So right now, the spotlight is right here. It's allowed to go 25 degrees that way, 25 degrees this way. The objects on the stage are the chair, the rug, the door, and the table. All right? The beam of light from the spotlight forms a 22-degree angle. Can the designer use the spotlight to light each of the objects on the stage? So, first thing I would do if that's what's written in my book is I'm going to sketch that on my paper. I don't have to have all the artistic stuff. I want to have the linear stuff on there. So I want to have all the angles and stuff. So I've got a chair sitting here, and I got a spotlight down here, and I got a rug right here. It doesn't have to be drawn to scale either. You notice I'm not measuring anything. I got a door over here, and I've got a table over here. Okay. Currently the spotlight is in this section here, so maybe I'll have like some stuff there to represent that's the spotlight beam going through there. Okay. Notice I didn't use a ruler, I just sketched it freehand, made it look kind of like what that looks like. I want to put any pertinent information in there such as angle measures they give me, and the ones they give me is from the chair to the rug, from the chair to the door. So from here all the way around to here, they're saying is 57 degrees. They're telling me that the distance from the rug to the door, that angle is 22 degrees. And they're telling me the angle from the chair to the table, which is this, is 74 degrees. They gave me the whole big angle, another angle that's bigger than just the two individual angles, and this really small angle here, that 22-degree angle. All right. Now, the problem states that the spotlight has the capacity to move 25 degrees this way, 25 degrees that way from where it currently is positioned right this second. So what I'm basically asking for on this problem is that less than 25 degrees right there? So we need to know that angle measure, and we need to know that angle measure. Is that less than 25 degrees? If it's less than 25, you're good to go. If it's not, it won't work, right? So what I'm looking for mathematically out of you is I want you to figure out how big those angles are, and then use that to answer the question. Can the designer use a spotlight to reach each of the objects? So let's work with the DST first. So if I want to find the measure of angle DST, looking at the given information, I got a 74-degree angle, a 57-degree angle, and a 22-degree angle. DST, which is this angle here, get my highlighter back here.
Why do you do M's for that?
It's just a mathematical symbol. Little m means measure of, and then angle. So if I want to describe a number, instead of the picture, I want to put the little m in front of it. Okay, so measure of angle DST. So DST is this angle here, right? So I need that angle with another small angle to make a big angle. So this with what other small angle makes a big angle? With 57 makes which one? 74, right? This little sliver here and this bigger wedge here combine to make the entire angle, right? Again, that's what the angle addition postulate is all about. Can I find two smaller angles that make a bigger angle? DST smaller, CSD smaller, together make CST the biggest, right? So what that looks like is measure of angle DST, I should probably put plus instead of equals, plus 57 degrees is equal to 74 degrees. So I'm just applying the angle addition postulate. A smaller angle and a smaller angle add to make the bigger angle. Small plus small equals big. Okay. Algebraic problem. This is representing an unknown, just like we had in the problems we did recently with x's, right? X was the variable. This is now the variable. So to find out what this equals, I have to move the 57 over. So I'm going to chop the 57, make minus 57 happen. I get the measure of angle DST is equal to 17 degrees. As long as it's less than 25 degrees, the spotlight is able to reach it, right? So its current position, 25 degrees to the right, will reach the table with no problem. If we want to look at the other angle in concern here, let's see. Let's go with
We don't need
the
to,
yellow white.
yes or no.
I want to find out how big this angle is.
So it's 17.
So which two smaller angles, this smaller angle and another smaller angle, make a bigger angle? This angle and which two?
40,
22 make which angle?
57.
57, right? Pretend that's yellow highlighted. So this angle and this angle add up to 57 because, again, the small one and the small one make the big one. Again, that's the angle addition postulate in action. So it looks like this. It's going to be the measure of angle CSR plus 22 degrees is equal to 57 degrees. Again, measure of angle CSR is the variable. We want the variable by itself, so everything else moves to the other side. So I'm going to chop the 22, move to the other side, becomes minus. The measure of angle CSR is equal to 35 degrees. Okay, so I'd expect in a word problem like this, you do the math, you get the mathematical answers, and then use that to interpret whether you can do what they're asking you to do or not. Is that going to work? No, because 25 degrees to the left is going to stop short of the chair, so the chair will never be in the spotlight. All right, so we can say that, can the designer use the spotlight? They cannot use the spotlight.
But no.
The stoplight. Do you just say no in English class? The spotlight. Spotlight. Well, that's good enough. I want complete sentences as long as it states the fact. I don't want just no. Answer the question they're asking.